Hey everyone, and welcome. Today, we're going to talk about a hidden force that quietly shapes our world, from the ups and downs of the stock market to the hot streaks and slumps on the sports field. It's a statistical idea that our brains are, well, almost designed to get wrong. And once you see it, trust me, you'll start noticing it absolutely everywhere. So, let's dive right in.
It all kicks off with a puzzle. Picture a flight instructor at an academy. He's noticed this really clear pattern. Whenever he yells at a pilot for a bad maneuver, they almost always fly better the next time. But when he praises a pilot for a perfect landing, they usually mess up the next one. And his conclusion? It seems totally obvious. Punishment works, and praise doesn't.
So, what do you think? Is he right? Does scolding someone actually make them perform better? And does praising them make them lazy? Just take a second. What's your gut instinct telling you? Well, the answer is actually way more interesting than a simple yes or no. Let's really break down the instructor's big mistake. Okay, so here's the big twist. The instructor wasn't making it up. He saw exactly what he said he saw. The pilots really did get better after he yelled at them, and they really did perform worse after he praised them. So his observation was spot on, but his conclusion? Completely and totally wrong. You see, the praise and the punishment had absolutely nothing to do with it. What he was really seeing was this incredibly powerful but invisible statistical force called regression to the mean. To put it simply, extreme performances, whether they're amazingly good or terribly bad, are by their very nature rare. They're statistical outliers. So it's just incredibly likely that the very next performance is going to be, well, more average. That pilot who flew badly, he was probably just having an off day, and he was bound to get better. And the pilot who flew perfectly, she had a great day, maybe a bit of luck, and was bound to come back down to earth. Okay, so let's dig into what this statistical gravity is all about and how it actually works.
Think about any performance with this simple formula. The outcome equals your skill plus your luck. Now, your skill is your true average ability. It's pretty stable, it doesn't change much day to day. But luck is completely random. It can be good, it can be bad, but the key thing is, over time, it always averages out to zero. So if you have an exceptionally great performance, it means you had your normal skill plus a huge dose of good luck. An exceptionally bad one, normal skill, huge dose of bad luck. And since big doses of luck rarely strike the same way twice, the outcome gets pulled right back towards your actual skill level.
Now, to really nail this down, there's one quick idea we got to talk about: correlation. It's really just a way of measuring how related two things are. You know, if one thing changes, how likely is the other thing to change along with it? And this is stuff you already know, right? The more hours you study, the higher your test score is probably going to be. That's a positive correlation. The faster you drive, the less time it takes to get to your destination. That's a negative correlation. And sometimes there's no relationship at all. But here's the crucial point. Unless two things are perfectly correlated, 100% linked, regression to the mean is always going to be a factor. And this is where it gets really fun, because once you get this concept, you start seeing it absolutely everywhere. It's been hiding in plain sight this whole time. I mean, think about the famous Sports Illustrated jinx, right? An athlete gets on the cover and then suddenly has a bad season. It's not a curse. They got on the cover because they had an exceptional performance, which was statistically very likely to be followed by a more normal, average one. You see it in investing all the time. And get this, you even see it in relationships. It's a statistical fact that extremely intelligent women tend to marry men who are less intelligent than they are, and vice versa. That's not some kind of social commentary, it's just progression to the mean in action. Okay, so if this thing is everywhere, why is it so hard for us to see it? Why did that flight instructor invent a whole story about punishment and reward instead of just seeing the stats? Well, the problem, it's us. It's our own brains. Our fast, automatic, intuitive thinking, what psychologists call System 1, it absolutely hates randomness. It demands a cause and effect story. He played better because I yelled. It's simple, it's clean, it makes for a satisfying story. Our slower, more logical brain, System 2, can handle the boring statistical truth, which is just, sometimes things just go back to normal. But our quick, storytelling brain almost always gets there first. So the big question is, how do we fight back against our own brains? How can we tame these intuitive guesses that lead us astray? Let's walk through a really practical example together. All right, consider this question. Mary was a very precocious kid. She started reading fluently when she was just 4 years old. Now she's a senior in college. What's your best guess for her GPA?
Now, your fast-thinking System 1 brain does something pretty clever but also wrong. It swaps out that hard question, what's her GPA, for an easier one, how impressive is it for a 4-year-old to be reading? And the answer to that is, wow, very impressive. Let's say that puts her in the 90th percentile of kids her age. Then your brain just matches that intensity, that 90th percentile feeling, to the GPA scale, and it spits out a number like 3.8. And it feels totally right, doesn't it? But it's wrong.
Your brain made a critical mistake. It acted like reading ability at age 4 and college GPA are perfectly correlated. But they're not. So many other things, luck, hard work, life events, happen between age 4 and 22. So to fix this, we have to regress our guess toward the average. Here's how. We start with the average GPA for a college student, which is about 3.0. Then we look at our gut feeling guess of 3.8. The difference there is 0.8. Now, we don't get to keep that whole difference. We only get to keep a fraction of it, based on how strong the correlation actually is. Let's just say it's about 0.3. So we add that small correction, just 0.24, to the average of 3.0. And that gets us to a much more realistic prediction, 3.24.
And just look at that difference. This shows it perfectly. Our intuitive brain jumps way out to an extreme 3.8. But the statistically sound, corrected prediction is a much more reasonable 3.24. We've dampened our initial guess to account for the fact that our evidence wasn't perfect. So, to wrap all this up, let's distill it down to 2 simple but super powerful rules that you can start using every single day. First, when you're looking back and trying to explain the past, remember the law of inevitable gravity. When you see an extreme result, just expect it to fall back toward the average. You don't need to invent a complicated story to explain why. It just does. Second, when you're trying to predict the future, use the dampening rule. If your evidence isn't perfect, and it almost never is, then pull your prediction away from the extremes and stick closer to the average. And ignoring these rules has some very real consequences. After a truly once-in-a-lifetime performance, Indian cricket selectors gave Dinesh Karthik a long-term spot on the team. They fell into the classic trap. They saw a lucky spike, this huge positive blip on the radar, and they mistook it for a permanent shift in his actual skill. And of course, the inevitable regression to his average followed.
So, I'll leave you with this question to think about. Look back on your own life, your career, your hobbies, that incredible sales quarter you had, that presentation that was a total disaster, that one project that went absolutely perfectly. How much of that was a real permanent change in your skill, and how much of it was just statistical gravity hiding in plain sight?